Let's make a generator expression. So if we take a list comprehension and we turn the square brackets into parentheses, this is no longer a list comprehension. This is called a generator expression. So list comprehensions give us back new lists. Generator expressions give us back generator objects. A generator object, unlike a list, doesn't have a length. And if we try to index a generator object to get its first item, for example, we'll get an error. You cannot index a generator. The only thing you can really do with a generator is loop over it. So why would we use a generator when it seems like it has fewer features than a list? So the benefit of generators is that they are lazy iterables, meaning they don't do work until you start looping over them. So this generator object at this point hasn't actually computed any values, and it doesn't contain any values unlike a list. Meaning if we were to take the number 4 in our original list and turn it into the number 5, if we then loop over our generator object using a list constructor or for loop or any other form of looping, we'll see that the fourth item isn't 16, it's 25. So generators don't do work until the point where you loop over them. And if you loop over them a second time, they'll be empty that second time. So generator objects are lazy iterables and they're single-use iterables. You can only use them once because as you loop over them, the items in them get consumed. And they don't just get consumed, they actually get generated at the point that you loop over them. So here we've fully exhausted a generator, meaning we've consumed all the items within it, but you don't have to do that when you loop over them. If we were to start looping over a generator object, and then we stopped when some condition was met, if we then started looping again, we would start up where we left off. So generators generate values as you loop over them. And generator expressions give us back new generator objects. The only thing you can really do with a generator object is loop over it. And once you've looped over it all the way, you've fully consumed all the items within it, and it's exhausted, it doesn't really have a use anymore. It's empty at that point forever. There is one more thing we can do with the generators though, and that is to use the built-in next function on them. Now this is a little bit unusual to see, but the next function gives us the next item in a generator. So generators keep track of where they are in the original iterable that they're looping over and which expression they need to evaluate on each item in that iterable. So as we call next on a generator repeatedly, we will get each of those items individually. And if we call next on a generator that's been fully consumed, that's exhausted, we'll get a stop iteration exception, indicating that there are no more values in this generator. It's empty. So list comprehensions make new lists. Generator expressions make new generator objects. And a generator is an iterable which doesn't actually contain or store values. It generates values as you loop over it, which means it's more memory efficient than a list because it doesn't really store memory to hold those values. It generates them on the fly as you loop over it. So generator expressions give you generators, which are lazy single-use iterables.